Without question, one of the greatest challenges to human health today is cancer.
1 of every 3 people gets some form of cancer during their lifetime, and that makes prevention, detection, and treatment of cancer a major focus of clinical practice and scientific research.
In the nearly 50 years since the US government declared a war on cancer, there have been many breakthroughs in our understanding in the treatment and management of this disease. Yet much about cancer remains an enigma, especially its ability to resist so many treatments that we've developed to attack it.
As other diseases become better controlled and people live longer, the impact cancer has on our society is only growing. In many communities, cancer has surpassed heart disease as the #1 cause of death. Why has this problem not been solved yet?
As the Chinese military strategist Sun Tzu wrote long ago, to win a war, you have to know your enemy. And in the case of cancer, knowing the enemy has turned out to be much more difficult than most of us expected.
The problem is one of stealth.
When the single cell that will eventually become the cancer, when it first steps out of line, it doesn't just go rogue. It stays stuck in a web of relationships that tie together every cell and all the tissues of our body.
Normally, these relationships force cells to cooperate as they make their choices to grow or divide or move or die.
What we've learned in recent years is that cancer cells don't just ignore these instructions, they exploit them. Cancer cells use relationships with other cells to their advantage, to ensure that they're not stopped by their neighbors, and even to promote their own growth at their neighbors' expense.
Cancer, as it turns out, is a disease of relationships.
And this means to understand cancer, we have to delve deeply into the complex networks of cell communication and cell cooperation that define how our tissues normally work.
With the hundreds of different types of cells in the human body, and with the several thousands of genes directly involved in cell-cell communication, this is a dauntingly complex task.
That's where systems biology comes in.
Systems biology is a new approach to research that relies on the power of interdisciplinary teams. Systems biologists concentrate on targeting those problems in the life sciences that are the most difficult because they're the most complex.
Arthur, John, and I co-direct the UCI Center for Cancer Systems Biology, which is an interdisciplinary center formed in 2018, last year, to apply the methods of systems biology to solve the problem of cancer.
In our center, we focus on several of the major cancer killers, including colon cancer, melanoma, and leukemia. Our research teams bring together experimental biologists, clinicians, mathematicians, engineers, and computer scientists.
In leukemia, mathematical models and computer simulations are helping us understand how different kinds of blood cells feed back upon each other so that they can control their overall growth.
And in melanoma, genetically engineered mice are helping us to understand how a single mutation can sometimes cause cancer, but other times simply produce a harmless mole.
And for colon cancer, we take advantage of recent technologies that allow us to measure the activity of thousands of genes in thousands of cells, individual cells, at the same time. This is helping us understand how cancer cells cooperate with each other, and importantly, how they interact with the normal cells that surround them.
And in pursuing this research, we collaborate as part of a network of 13 cancer systems biology centers spread across the nation, a sort of dynamic research consortium that was established recently by the National Cancer Institute. Together, as part of this consortium, we share data, results, and insights into virtually every major type of human cancer.
By leveraging the latest ideas and technologies to bring greater understanding to the problem of cancer, we aim to transform our society's ability to tackle this important problem in human health.